The World Health Organization defines air pollution as contamination of the indoor or outdoor environment by any chemical, physical, or biological agent that modifies the natural characteristics of the atmosphere. Basically, air pollution is anything in the air that we don't want to be there. We tend to characterize this into two general types of pollutants, gases and particles. We do this because gases and particles often come from different sources and are removed by different processes. Let's start with gases. An example of a natural occurring gas in the air is oxygen, something we're very grateful for. For gases that we consider to be pollution, we're talking about individual chemicals or molecules that come from lots of different sources. One important source of some gaseous pollutants is combustion, or burning. Indoor combustion happens when we use appliances like stoves, water heaters, or furnaces that run on natural gas fuels. Combustion can produce many different pollutant gases, most notably carbon monoxide, nitrogen oxides, carbon dioxide, and volatile organic compounds, or VOCs. Exposure to carbon monoxide makes it harder for our bodies to use oxygen and can lead to fatigue, headaches, or dizziness. We experience similar symptoms when exposed to high levels of carbon dioxide. Nitrogen oxide exposure can irritate your eyes, nose, throat, and lungs. Combustion in gas stoves and other similar sources tends to be pretty inefficient, which means that they also release many different leftover chemicals that are made when the natural gas is not completely burned or when there are contaminants in the natural gas to begin with. These chemicals are part of a broad group of molecules called volatile organic compounds, or VOCs. There are lots of sources of VOCs indoors besides combustion. This includes air fresheners and other scented products, most cleaning supplies, adhesives, solvents, pesticide sprays, and even food, especially when it's being cooked. In fact, lots of materials will off-gas or release VOCs, but this usually goes away over time. Think of the smell of a freshly painted walls or that new car smell. That's from VOCs. Some examples of VOCs commonly found indoors include formaldehyde, ethanol, aromatic compounds such as benzene and toluene, and terpenes. Different VOCs have different effects on people, but in general we can say that exposure to VOCs can irritate people's eyes and throat and even cause headaches. Some people are really sensitive to VOCs, even those that others might like the smell of, like perfumes, and some VOCs are known to cause cancer. The other category of air pollution besides gases is particles, or particulate matter. Some examples of naturally occurring particles in the air are dust and pollen. These particles are between 2.5 and 10 microns, which is about 10 times smaller than the width of a human hair, but relatively large in terms of particle sizes. We can often see them floating around in the air, especially if the light hits them just right. Large particles are sometimes called coarse particulate matter, or PM10, and they can deposit in your nose and throat, causing irritation or other allergic responses. While pollution also contributes to PM10, we're especially concerned about particles that are smaller than 2.5 microns, called PM2.5. They're so small that you can't really see them with your eyes unless there's so much present in the air that it makes it hazy. When we breathe in these small particles, they can get deep into our lungs and even our bloodstream. Exposure to PM2.5 can make existing respiratory issues like asthma or COPD worse, or even trigger heart attacks or strokes. And exposure to some types of particles can even increase cancer risks. Not all particulate matter is the same. We can think of PM10, the large or coarse particles, and PM2.5, the small particles, as a collection of individual particles that can be made of different substances and have different sizes. The composition and size of these particles depends on their source. There are many common indoor sources and activities that generate particles, like cooking and combustion. Think about gas stoves and other appliances, fireplaces, candles, incense, and of course smoking, among others. Some printers release particles, especially laser jet ones. Even some cleaning activities can produce particles. For example, vacuuming can kick dust into the air. Particles can also be made from chemical reactions that occur in the air involving VOCs, the gases that we spoke about earlier. Some of these sources make particles that are quite small. Remember how we compared to a human hair? Hair is about 50 to 100 microns across. PM2.5 is all the particles that are smaller than 2.5 microns, and that's a lot smaller than hair. And some particles are only 0.1 to 0.3 microns in diameter, even 10 times smaller than that sometimes. This range matters because the size of particles has a major influence on what happens to those particles once they're released into the air, which we'll talk about more in a later module. For now, it's enough to know that a particle's size is strongly related to how long it will stay suspended or floating in the air. In talking about sources of gases and particles in indoor environments, we've not yet spoken about one other big source. That's us, people. We're sources of some of the pollutants that we care about. Let's break this down. First, the amount of carbon dioxide in our exhaled breath is very high, about 100 times higher than the amount in outdoor air. So just by breathing, we're adding to the amount of CO2 in a room. In fact, in many indoor environments, we're the major source of CO2, especially when there's a lot of people packed into a room. Second, there's lots of other chemicals, including VOCs, in our breath. We may off-gas VOCs too, especially if we're wearing scented lotions or perfumes. People also emit particles into the air. First, we're continuously shedding little flakes of skin. The outermost layer of skin is shed and replaced every 4 weeks. And because lots of organisms live on the surface of our skin, collectively known as the skin microbiome, skin shedding can carry along some of these organisms that can deposit on room surfaces or even other people. Second, when we exhale, our breath carries particles that are generated in the respiratory system. While the number of particles we exhale is very small, there's a chance that some of these respiratory particles are carrying germs, that is, viruses or bacteria. Respiratory diseases are transmitted when others inhale these germ-containing particles and they deposit in our lungs. Certainly this is something we want to avoid, and we'll talk about this in the second set of modules.